Okay, I'd like to briefly talk about integration for Physics 2211 because some of you you'll be in Calculus 1 right now and you won't have seen integration at all by the time we start physics. So this is just a brief overview. Again, your calculus class is going to do a much better job of explaining integrals. But the basic idea of an integral is what you do is if you start with a function, in this case velocity is a function of time, you break this down into a bunch of finite steps. So like imagine this point and 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 this point. And the idea is what you're going to do is you're going to take the value of the function at that point and then multiply it by delta t. So what I think you can see is that if I take the value of the function here and multiply it by delta t, that is the time step between each of these points, that's going to give me the area of this rectangle. And then if I take this function and multiply it by delta t, it's going to give me the area of that rectangle, and then the area of that rectangle, and then here it's going to give me the area of that rectangle, and then here the area of that rectangle, and that rectangle, and that rectangle, and then 0, and then that rectangle, and then that rectangle, and then that rectangle, and there, and there, and there, and there. And this symbol says add them all up. And if I add up all of those areas, I will get an approximation of the total area under the curve. Well, what an integral does is it says, okay, let's break it up into more and more and more little pieces. So instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, instead of 17 pieces, let's double that and break it up into a lot more pieces, and then we're going to get an even better estimate of the area under the curve, and then double that and break it up into even more pieces, and then in the limit, as the space between these pieces goes to 0 and we end up with an infinite number of steps along the curve, that is what becomes an integral. So an integral is a way of determining the total area between the curve and the 0 line. And importantly, anything above the 0 line is a positive area, and anything below the 0 line is a negative area. And so, if we were to calculate the integral for this function, we would have some positive value for the first part of the integral and some negative value for the second part of the integral, and then the total integral would be the positive minus the negative. Okay, so that's what an integral is. This has a lot of different useful, there's a lot of times in physics where this is a useful thing to do, and I just want to very quickly talk about how we calculate an integral. So the way we do an integral is basically an antiderivative. It's like the opposite of doing a derivative. So if we say, for example, take the integral of 5x squared dx, this is how we write it. So the thing we're taking the integral of is between this this operator, this symbol, which looks like a really tall s, but it's just an integration symbol, and the dx tells us what it is we're integrating, what variable we're integrating. So in this case, we're integrating x. Okay, so that's going to equal some other function. And the way we find the function that goes here is we say, okay, well, what function, if we took its derivative, would become 5x squared? And it makes sense that it would have to be an x cubed, because when you take the derivative of x cubed, you get x squared. But when you take the derivative of x cubed, you get 3. So the constant I would need out in front here would be 5/3 x cubed. And why? Because if I take the derivative of this, the 3 comes down and cancels with the 1/3, and I end up with 5x squared. But this isn't the only function that works. I could also have 5x squared plus 10, for example. Because if I take the derivative of this, the 5/3 x cubed becomes 5x squared, and the 10, when I take the derivative of the 10, it becomes 0. So I could have a 10 there, but of course it doesn't have to be a 10. It could be a pi. Because if I take the derivative of pi, that's a constant, and it'll become 0. And I hope you see that actually any constant would work. So when we're doing just an antiderivative like this, when we're doing this is called an indefinite integral. Or an antiderivative. When we do an indefinite integral or an antiderivative, we oftentimes, or I think always, need to add a plus c, some constant. It could be any constant, because when we do this integral, we don't know what constant we started with. I hope that makes sense. If I took the derivative of this function, it would become 5x squared. So the integral of 5x squared is this function, 5/3 x cubed plus any constant. Okay, so that's the basic idea of how we do integrals. They're basically antiderivatives. Then there's one other thing I want to mention, is that we can also have what's called a definite integral. So let's say we wanted to integrate 5x squared dx, but we specifically wanted to integrate from 3 to 5. That is, we're going to start at x equals 3 and go to x equals 5. So what would this look like on a graph? We'd start with that function, 5x squared. The function 5x squared looks like a parabola. And if we start at 3 and we go to 5, we're finding the area of that, the area below the 5x squared and above x equals 0, or y equals 0. So we'd be finding this area. And how do we find that area? We first do the integral. So this would be the integral of 5x squared is 5/3 x cubed plus a constant. And then we evaluate this thing from 3 to 5, meaning we first plug in x equals 5 to this equation, and then we subtract x equals 3 from this equation. And the reason for doing that is when you plug in x equals 5, you get this whole area from here to here. And when you subtract x equals 3, you're subtracting this partial area from here to here. And that leaves us with the area we wanted. Okay, so when I plug this in, I get 5/3 times 5 cubed plus c minus 5/3 times 3 cubed plus c. And right away, the first thing that happens is I have a plus c here, and when I distribute that minus sign, I have a minus c there, so those constants cancel. So for a definite integral, we don't need to worry about adding the constant. When we have limits on our integral, we don't need the plus c as part of our integral. We're just going to evaluate this 5/3 x cubed from 5 to 3. Okay, so in this case, 5/3 times 5 cubed is 5 over 3 times 5 cubed is 625 over 3, and 5 thirds times 3 cubed is 135 over 3. So that's equal to 625 minus 135. That's equal to 490 over 3. So that is the answer for that integral. Okay, very quick, short introduction to integration. What does it mean? How do we do it? And we will certainly talk about this more in class, and you will certainly learn more about this in your calculus class. But I just wanted you to see what integration is before we get too far into the class.